for this. Ha? May klase ako. Okay, so far on the previous meetings, no, last meeting, we have tackled batch distillation, that is also known as differential distillation, yung may Rayleigh equation, ano, at saka steam distillation. So today we're going to discuss fractional distillation. So ang fractional distillation ay multi-stage distillation. So as you can see, itong mga lines na to, horizontal lines na to, this represents plates, ano? So kamukha nung sa absorption tower, they are pwedeng sheave tray lang, pwedeng bubble cup, plate trays, ano? Okay, so right here we have the feed. Tapos we're concentrating this to produce your distillate. Actually, we're separating, we're separating chemical components, ano? So some of the chemical components goes to the bottoms, and then some of the chemical components goes to the distillate. So kaya yung tawag natin dito hindi na waste, ano, bottoms product na. So halimbawa crude oil distillation, so pwedeng dito asphalt, dun sa taas ay gasoline, diesel, ano. So hindi na siya waste, bottoms na siya. Tapos generally above the feed, ang tawag dun ay enriching section. So basically yun kasing concentration ng more volatile component becomes higher above the plate where you introduce the feed, above the feed plate. So this is the enriching section. Tapos yung sa baba naman is the stripping section. So if you still remember di ba yung gas absorption, merong yung kabaliktaran ng gas absorption is stripping, parang ganito rin dito, kasi basically ang nangyayari dito yung imbis na 'di ba pag gas absorption yung gas nagta-transfer sa liquid, so dito stripping baliktad yung some of the components of the liquid goes to the vapor, kaya stripping section to. Anyway, basically stripping section siya kasi relatively pababa yung concentration ng more volatile component. Okay, any questions so far? Enriching section, we increase the concentration of the volatile component, in this section sa upper part. Tapos sa lower part, generally the concentration here is lower than the concentration in the feed of the volatile component. Kaya stripping section. Any question? So meron tayong additional two components. We have right here, we have the reboiler. Ayun. I hope you can read this. This is the reboiler. So the reboiler boils, it boils the liquid coming out of the tower, yung bottoms product. It boils it, and then some portion of it evaporate, and then the vapor is returned to the column, So ganun yung function ng reboiler. So generally we use steam to heat the liquid and to produce the vapor, So pag nag-field trip kayo, generally parang usually ang reboiler lang siya. Parang part siya ng column, nasa ilalim siya ng column. It's not really a different unit, Tapos another part is the condenser. So yun yung condenser, So ang condenser naman, ang function niya, yung vapor na lumalabas dun sa tower, kino-condense, kaya condenser. Ano? So we produce a liquid. So some part of these liquids are is returned to the column. We call that the reflux. No? Tapos yun, siyempre yung iba, what we withdraw is the distillate product. Question? Okay, so let's tackle the mathematics, no? In multi-stage distillation. Okay? So we're going to perform an overall mass balance and component balance right here, to derive the operating line equation. So ano ba yung operating line equation? Yung operating line equation, plot siya, it's a linear plot of x1, y2, no? Ito yung x, ito yung y. So as you can see, x1 and y2 belongs to this area, no? It's between the first plate and the second plate. Tapos yung second point niya ay x2, y3, no? Parang ganun. Tapos x3, y4. Pero as you can see, all the points, all the x and y's, no, coordinates are concentration in this area, no? They belong to this area, then they belong to this area. Na imagine nyo ba? It's between the first plate and the second plate for x1 and y2. And then between second plate and third plate for x2 and y3. Ganun, ganun yung operating line. So, yung concept kasi ng operating line, this is used to determine the number of theoretical stages. So ang tawag dun sa method that uses the operating line is the McCabe-Tell method. So McCabe, yun yung isa nating libro, di ba? Tapos Tell, T-H-I-L-E. McCabe-Tell method. So this is known as the McCabe-Tell method. So basically ang end product ng process will be the number of theoretical stages, So pero hindi pa yun yung actual number of plates, you need to still to divide it with the efficiency. So pag dinivide niyo ng efficiency ng bawat plate, yung theoretical number of plates, you will get the actual number of plates. So plate here, I'm speaking of yung kamukha nung sa gas absorption, no? Siguro naman kasi hindi ko na inuulit dito yon, na-introduce na sa inyo yung mga types of plate. 'Di ba, Sam? You're familiar with sheave tray? So what is a sheave tray, Sam? Can you describe a sheave tray? Sure, Mike. What is a sheave tray?
Hello?
Oh, yes, I can hear you.
Salaan po, sir. Parang salaan.
Yes, may mga butas,
Opo.
So, ganun lamang yung sheave tray, may mga generally circular yung shape niya, tapos may mga butas lang. Sheave. Tama, very good. Sheave tray. Tapos halimbawa, yung isa pa yung bubble cup. Oh, what about bubble cup, Patrick? Tandaan ko ba kung can you describe a bubble cup tray? What's the difference between a sheave tray and a bubble cup? Patrick. Yeah, go Patrick. Yeah, what's a bubble cup? Do you have an idea? What a bubble cup tray is?
Ay, wala. Ano po? First time ko po narinig, sir. First time ko po narinig.
Yung namang bubble cup, di ba pag sheave tray, butas-butas lamang yung tray, Pero Patrick, alam mo naman yung sheave tray.
Opo, sir. Alam ko po yun.
Shift tray, halimbawa ito shift tray, tapos may butas siya, halimbawa ito yung butas niya. So pag bubble cup, you attach another parang device, no? Ang tawag doon is a bubble cup. Basically ano siya, meron siyang cover. So ito kasi 'di ba lang hole lang, mga holes lang yung pag shift tray, mga holes lang na ganun. So yung bubble cup, ibig sabihin may takip, no? So, ang itsura niya, parang may wall siya na ganyan. Tapos, meron siyang movable cover. May movable cover siya. So, pag mataas enough yung pressure ng gas, aangat yung cover. Tapos, makakalabas yung gas. No? Pag mababa yung pressure, hindi aangat yung cover. So, this is within the plate. Marami yan. Several of this within the plate. Parang may cover lang na ganun. So, yun naman yung bubble cup, This is shift tray, that's bubble cup. At least na-discuss naman sa inyo yung shift tray. Okay? So, at least may idea kayo kung ano yung kina-calculate natin dito, Basically, binibilang natin kung ilang shift tray yung ilalagay natin doon sa loob ng distillation column. Okay? Okay, so what we're going to do is we're going to make an overall mass balance dito sa rectifying section. We're on the rectifying section, meaning dun sa taas, sa taas ng column, sa taas ng feed. Ito yung feed. So yung sa taas doon tawag ng rectifying column. So ito yung dito tayo magma-mass balance dito sa nakakulong na to. So for example, ito pumapasok to, this is Bn plus 1. Tapos lumalabas to, this is L sub n. No? Tapos ito yung D. This is the distillate. So pag nag-mass balance kayo, ito lang yung pumapasok. Bn plus 1. Tapos yung lumalabas, L sub n plus D. Question. Do you have any question regarding overall mass balance? Okay? Tapos, component mass balance. So the first equation is overall mass balance. This is overall mass balance. Tapos yung pangalawa, this is component mass balance. So yung concentration ng Bn plus 1 is Yn plus 1. Yung concentration ng D ay Xd. Yung concentration ng Ln ay X sub n. So pag nag-component mass balance tayo, Bn plus 1 times Yn plus 1. No, yun yung pumapasok kasi is equals to L sub n times X sub n plus D Xd. Do you have any question regarding the component mass balance? So wala naman, madali lang naman, kaya yan. So what we're going to do is we're going to transpose yung Bn plus 1 sa kabilang side. So parang i-multiply nyo lamang ng 1 over Bn plus 1 yung equation. So nandito na siya, So we have here the operating line equation. So sa McCabe-Tell method, ang gagawin natin, we need to plot this operating line dun sa phase equilibrium, dun sa phase curve ng dinidistill natin, So ito yung line equation, So to plot this, generally ang kailangan natin is the slope and the y-intercept, So this is the y-intercept, dxt divided by bn plus 1. Tapos ito yung slope niya, L over B. Ln divided by Bn plus 1. Okay? So as we go along, we'll discuss 3 more lines. And then generally, the operating line equation, the slope of the operating line equation is palaging L over B. Palaging L over B yung slope. Okay? Yun yung ginagawang stock knowledge. Slope is always L over B. Any question at this point? Do you have any question at this point? Let's proceed. If you don't have any question. Ito yung sinasabi ko sa inyong equilibrium curve. This is the liquid vapor equilibrium curve. So in particular, this is for benzene and toluene. So itong curve na to, ito yung concentration ito yung curve ng mole fraction of benzene in the liquid, X sub A, versus mole fraction of benzene in the vapor, Y sub A. Imagine nyo ba? halimbawa, you place at a certain temperature, no? You place benzene toluene, no? Benzene toluene solution in a container. So ito yung liquid, tapos ito yung vapor, ito yung gas, no? So ang pinlat natin yung concentration dito ng benzene, XA, tapos yung Y sub A, yung concentration dito sa vapor. No? Halimbawa, ito yung solution natin, yung concentration niya X sub A. Halimbawa, you have 10% benzene dissolved in toluene. Parang ganun, ano? So yung X sub A niyan, 0.1. So dito yun, ano? Dito yun. Tapos, we measure the concentration in the vapor, in the gas. So halimbawa, sa benzene, ano lang, ilan ba yun? Yan, mga 0.15, no? 0.15 yung concentration ng benzene sa gas. So ito yon, ito yung point na yon. Okay? You understand this curve? So you might be asking, bakit meron ditong straight line? Actually, this is a diagonal, 45 degrees line. So sabi ng mga libro, they just place it here para makita nyo na yung pinaplot nating concentration is the more volatile component. Kasi as you can see, the curve is above the 45 degrees line. Ito kasi yung pag-equal, di ba? Kumbaga, halimbawa, pag 0.4 yung X sub A nyo, tapos 0.4 din yung Y sub A. So ito yung parang equal yung volatility. So ang pinaplot natin generally, yung mas volatile component. Kaya it is always above the 45 degrees line. Okay? So ito yung gagamitin nating equilibrium curve sa McCabe-Tell. Basically, di ba, napag-aralan na natin yung rectifying section line. Ano? So to plot the rectifying section line, generally ang first point nun ay, ito, is XD. No? XD, remember, XD is the concentration of the distillate. Yan yung first point niya, XD. Tapos, in order to plot that, you need to find either the slope or the y-intercept. So halimbawa, alam niyo na yung slope, di ba? Ang slope naman, L over B lang, So just draw a line with this slope. O kaya yung y-intercept, di ba? Yung y-intercept, halimbawa, ang y-intercept niya may formula din lang, di ba? Yung kanina, yung dxd divided by b. So halimbawa, na-calculate niyo yung y-intercept, no? Halimbawa, 0.2. So pagdudugtungin niyo lamang, di ba? This is the y-intercept, Pagdudugtungin niyo lang to using a ruler. O kaya using paint, no? You just draw a straight line between 0.2 and xd. Ganun lang. So yan, you have drawn the rectifying line. So ang ginagawa sa McCabe-Tell, you need to draw the rectifying line, you need to draw the feed line, no, you need to draw the stripping section line, no? Tapos pagkatapos doon, gagawa lang kayo ng mga stairs, no, steps. Yan. Bilangin niyo lamang yung number ng steps. So kung ilan yung steps, yun din yung number ng theoretical stages. No? Hanggang makarating kayo dito. Dire-diretso lang. Ganun yung McCabe-Tell method. Okay, so do you have any question? Okay. Yan. Parang ganyan, so that you will have an idea kung paano ginagawa yung McCabe-Tell method. You need to plot the 3 lines. And then after plotting the 3 lines, you need to do these steps. This one. So the number of the steps, halimbawa, 1, 2, so on, corresponds to the number of theoretical stages. This is the McCabe-Tell method. Yeah, you can find the operating equation on Terry. Halimbawa, nakalimutan nyo, no? So ito yung operating line equation natin. Y sub n is equals to L over B times X sub n plus 1 plus dxt divided by D. Alam niyo naman yung meaning, So Y, this is the concentration of the vapor. X, this is the concentration of the liquid. L, this is the liquid stream, no? Liquid flow rate. B, this is the vapor flow rate, molar flow rate actually. And then D, this is the distillate flow rate. XD, this is the concentration of the distillate. Okay, so usually sa problem, let me introduce to you the concept of reflux. So ang tawag dito, hindi kasi lahat nung lumalabas sa condenser, this is a condenser. Hindi lahat ng liquid na lumalabas sa condenser Usually ano yan total condenser, no? Pag sinabing total condenser, lahat ng pumapasok sa condenser, nililiquify niya, just like this one. No, nililiquify niya. Tapos yung lumalabas dito na liquid, hindi naman lahat wini-withdraw as product. So para mas mataas yung concentration ng distillate, usually ang ginagawa, merong portion na binabalik, no? Itong L na to. So actually yung L na yan, ang tawag diyan ay the reflux. Okay? Tapos yung ratio ng reflux L, now yung ratio ng L dun sa distillate, ang tawag dun ay the reflux ratio. So R is the reflux ratio. Okay. So there is a shortcut equation sa pagka-calculate ng slope. 'Di ba? Ang slope natin ay L over B, no? So i-express nyo to in terms of the reflux ratio. So for example, 'di ba yung L ay R times D, no? So RD. Tapos pag nag-ano kayo dito, nag-mass balance kayo sa condenser, yung overall mass balance sa condenser or overall mole balance, 'di ba? You will see that B, no, B1 is equals to L plus D. Actually, this is B1, ano? Mamaya makikita nyo, ang B naman constant, ano? So, this is also equal to B1. So, pwede nating i-replace yung B ng L plus D. Nakita nyo ba ito? So, B, tapos ito yung L, ito yung D. No? Replace natin yung B ng L plus D. Tapos again, may L na naman doon. So, we'll replace that with RD. RD plus D. No? So, if we're going to simplify this, you can cancel out the D. And the slope equation, the shortcut slope equation is R over R plus 1. So, mas mabilis ito kasi generally sa problem, given ng R. No? So, pag given ng R, in order to calculate, diba, tinatanong yung slope ng, kasi ano naman sa board exam, wala naman talagang graphical problem. No, hindi naman talaga kayo mag-graph diyan. So ang mga tanong lang diyan is what is the slope? May tatanong na makaital, pero what is the slope? What is the y-intercept of the of the feed line, what is the slope of the stripping section, ganon, So, yun. So that's why you need to remember this equation, mas mabilis siya. Actually, kahit di mo naman to memorize, you can syempre, you can calculate L by multiplying R and D kung alam niyo yung D, no? Tapos once you get L, di ba L over B lang naman, So you can calculate B using this equation, overall mass balance. Kaya lang mas mahaba, you will undergo several stages. Samantalang kung alam mo tong R over R plus 1 lang ang slope, diretso lang, isang step lang, no? So yun, you can find this on equation 13.25, Yun, page, I think this is the page, itong 13-19, umangat lang. Yun yung page 13-19. Question? Now, let's proceed sa stripping section. Ganun din, mag-overall mass balance din tayo. Tapos, this is the component balance, no? So, dito tayo mag-overall mass balance. So, meron tayong W, tapos BM plus 1, no? Ito kasi yung ating line. So, meron tayong L sub M. Okay? So, ang pumapasok natin ay L sub M. Ito, So, we have, ang ating overall mass balance ay L sub M. Kasi ito yung pumapasok, di ba? Tapos yung lumalabas, this is equal to BM plus 1 plus W. So, pag nire-arrange nyo to, in-isolate nyo yung BM plus 1, no? You will have BM plus 1 is equals to L sub M minus W. Do you have any question regarding this overall mass balance? Tapos yun, the concentration is of BM plus 1 is YM plus 1. The concentration of W is XW. The concentration of LM is Ano bang concentration ng LM? Ito, X sub M. Ano? So ikabit nyo lamang yung mga concentration dun sa LM, XM, minus W, XW. So we have this component mass balance. Tapos ganun din, i-transpose nyo lamang yung BM plus 1 sa kabilang side. You will have the operating line of the stripping section. So ganun pa rin. As you can see, yung slope niya L over B pa rin, di ba? Tapos ito yung kanyang y-intercept. Pero in practical for practical purposes, generally sa mga problems, halimbawa nagma-capital kayo ito yung equilibrium curve natin, benzene toluene So halimbawa nagawa niyo na plot niyo na yung rectifying section line. This is XD XD. Okay? Ginawa niyo na yan. Ito yung y-intercept niya halimbawa. Okay? Generally, sumusunod na ginagawa nyo, pina-plot nyo yung feed section. Ang feed section, madali lang namang i-plot. Usually, ang first point niya, XF. Kung ano yung concentration ng feed. Tapos, calculate nyo lang yung slope. Halimbawa, na-calculate yung slope. Halimbawa, infinity yung slope niya. So, nakatayo lang siya, Ayan. Tapos, in order to plot the stripping section line, magsisimula lang kayo dito sa This is the first point of the stripping section line. Like analogous to the rectifying section line, ang first point niya ay XW. So, ang gagawin niyo lang, idudugtong niyo lamang dito sa intersection ng feed line at saka ng rectifying section line. Yung XW. Generally, hindi na kayo nagka-calculate ng slope or kino-compute yung y-intercept. Dugtong lang. XW lang tapos dugtong lamang dun sa intersection ng rectifying section line at saka ng feed line. Okay? Tapos yun, pwede na kayo mag-stage up, di ba? Do you have any question at this point? Pero kung minsan, pwede rin pa-calculate sa inyo yung slope, tsaka pwede rin pa-calculate sa inyo yung y-intercept ng stripping section line. So ito lang naman yung formula. You can also find this sa handbook. Okay? Nandun din yan, page 19. Question so far? Ito. Andito rin sa Perry yung So, ang tawag lang niya sa L sa baba, sa stripping section ay L prime. Tapos B prime yung B. Kasi magkaiba, halimbawa ito yung distillation column. Sana you're still with me. Halimbawa ito yung distillation column. Ito yung feed, So dito sa plate, dito sa plate na ito pumapasok yung feed. Tapos ito yung rectifying section. Yung lahat ng B dito sa taas, equal. Yung lahat ng L dito sa taas, equal. Ganun yung assumption ng McCater. Kaya lang may papasok kayo ditong feed. So pagpasok ng feed, halimbawa liquid siya, halimbawa may liquid, may gas. So syempre, yung feed sasama siya dito sa L. So kaya dito sa baba, iba na yung value ng L, hindi ng L prime na. Yung B, ganun din. Kung may vapor siya, iba na rin yung value ng B, magiging B prime na. So that's why yung equation niya, L prime, B prime na. Okay? Question? So let's proceed. Tapos this is the feed section. This is F. Tapos yung feed, pwede siyang merong vapor part, tapos pwede siyang merong liquid part. Tapos we need to define Q. So yung Q, ito yung liquid, liquid, mole fraction ng liquid. Mole fraction of liquid in the feed. Halimbawa, your feed is saturated liquid. So for example, your feed is saturated liquid. So, ang Q will be equals to 1. Ganun lang. Kasi mole fraction siya ng liquid in the feed. Okay? So let's perform kamukha nung ginawa natin kanina. Let's try to perform some overall mass balance and component balance in order to derive this equation. Ano? So actually ang mahalaga dito yung slope ng feed line. Itong Q slope is equals to Q divided by Q minus 1. Okay, so halimbawa ito yung feed. Masok siya, no? Tapos meron siyang liquid component, let's call that LF, no? Tapos meron siyang vapor component, let's call that BF. So halimbawa, yung concentration ng LF, let's call that X. Yung concentration ng BF, let's call that Y. Tapos yung bawa yung concentration ng F, diba? Say F, ano? Let's call that say F. Okay. So basically, ang gagawin lang natin, mag-ano lang tayo, component mass balance. So pag nag-component mass balance kayo, F, ZF is equals to BF times Y plus LF times X. Do you have any question at this point? So just like what we've done before, isolate lang natin itong Y. So pag in-isolate niyo yung Y, you will have Y is equals to F say F minus LF times X. Tapos divided by BF, ano? Divided by BF. So, as you can see, ito ulit yung slope natin, ano? Negative LF over BF. So, pasok niyo lamang yung concept ng Q. 'Di ba sabi ng concept ng Q, yung LF ay equal sa Q times F kasi mole fraction siya ng liquid. Tapos yung BF naman, so yung vapor is 1 minus Q, ano? So 1 minus Q times F. Any question? You have any question at this point? Naintindihan ba to? Kasi 'di ba we define Q as the mole fraction of liquid. So when you multiply the feed with the mole fraction of liquid, you're going to find L, the liquid fraction. The flow rate of the liquid. Tama? So when you get 1 minus Q, tapos multiply nyo sa F, you will have the BF fraction. Or the BF flow rate, the vapor flow rate coming from the feed. So, yun. So pag sinubstitute nyo lamang dun sa negative LF over BF, itong dalawang equation na to, you're going to arrive with the slope Q over Q minus 1. This is the slope, negative LF divided by BF. Ulitin ko negative LF divided by BF. So substitute nyo lang. QF, okay na natin yung negative, divided by 1 minus QF. So magka-cancel yung F, ganun yun, ano? Magka-cancel yung F. Tapos yung negative ipasok dito sa baba. So, is equals to Q minus 1. Okay? So ito lang yung calculate sa feed section. Ikaw ba yan, Pai? Ikaw yung nagbe-message. Dali lang. Oh my God. Board exam kasi bukas eh. Everybody's excited. Matuloy din sa wakas. Do you have any question? Yun. So pag feed section line, kailangan yung i-calculate yung slope. And then you need to remember this formula, ano? Q minus 1. Dali lang. So, summarize natin, ano? Dito kayo sinasabi ko sa inyo. Limbawa, dali lang ha, ano ko lang sila, i-mute ko lang sila. Ano siguro yun? So, ulitin lang natin, ano? Why do we need this slope formula? This is the slope of the feed line. Q divided by Q minus 1. If we have the ano, the equilibrium curve. So, the first thing you need to plot is the rectifying line, no? So, first point niya, XD, XD. No, this is yung concentration ng distillate. Tapos generally, you calculate the y-intercept. Ikaw ata na-discuss sa inyo yung formula ng y-intercept nito. Ano, parang hindi natin nadaan. Yung y-intercept ng rectifying line, di ba kanina nabanggit na derive natin ang formula nun ay dxd divided by b. No? So may shortcut equation din yan. Ganun din, gawin niyo ring ano, ipasok niyo yung concept ng reflux ratio, no? So y-intercept is equals to dxd. Tapos yung b palitan niyo ng d plus l, no? Tapos yung l palitan niyo ng rd. So y-intercept is equals to dxd d plus yung l, di ba, rd. Tapos i-cancel niya lahat ng d. So ang y-intercept ng ang shortcut equation sa rectifying line na y-intercept is, make note of this, and this is also important, very important. xd divided by r plus 1. Hindi ko alam ba't hindi lumabas sa PowerPoint. Baka mamaya pa. Okay? So that's how you calculate the y-intercept. xd divided by r plus 1. Remember, the slope is r over r plus 1. Pero generally, pag nagmama-cable, medyo mahirap gamitin yung slope. Mas simple yung y-intercept sa rectifying section. Ano? So, this is a very important equation. Okay? So, y-intercept is equal to xd